Hello, good morning students. Here we are again under Exploding Chemistry teacher Susan. Today we are going to look into thermochemistry under the heat of combustion. What is combustion? Combustion of hydrocarbon or alcohol involves the breaking of covalent bond in between the atoms in alkane, alkene or even alcohol. There are two situations. In complete combustion, which means with excess oxygen, the product form will be carbon dioxide gas and water. While if it is an incomplete combustion, which means limited oxygen is supplied, they will form carbon monoxide or carbon with water. Now what you can see on your screen is the general definition for heat of combustion, which is heat change when one mole of fuel or substance is burned in excess oxygen gas to form carbon dioxide gas and water. Before we proceed on, let's have a look at a video on how do we carry out heat of combustion. Okay, before we start the experiment, as usual, we are going to take down the initial mass of the alcohol that we are going to use. And after that, we are going to measure a certain volume of water and pour it into a copper can. Then we shall take down the initial temperature of the water in the copper can before we start lighting up the alcohol and put the fire underneath the copper can to heat up the water in the copper can up to the certain thermometer reading that we want. Always observe the rise of the thermometer reading. When we have achieved the thermometer reading that we want, put off the flame and also take down the final mass of the alcohol used. Oh yeah, never forget to record all the data because we might need them for the calculation later on. Alright guys, after we have watched the experiment on carry out heat of combustion and to get the value to determine the heat of combustion, let us now also look at what is operational definition. The operational definition normally should be done based on the situation given as I show you here, C2H6 plus 3 oxygen to produce 2 carbon dioxide gas and 2 water. So what is your answer? Well, the answer is quite pretty easy. It just needs to change the word fuel or substance into ethane, because C2H6 basically is ethane gas. So it will be heat change when 1 mole of ethane is burned in excessive oxygen gas to form carbon dioxide gas and water. Well done guys. Alright guys, what you can see on your screen now is a typical SPM questions asking you to draw a functional diagram to give you 2 marks. And I also add in the 3 types of fuel or substance that can be used in determining the heat of combustion. They are alkane, alkene, or even alcohol. Okay, let's not think about the functional diagram already. So now it's time for us to balance the following combustion equation. They are equally important in your SPM. So it is your time now. We will check the answer after this. Alright? Do your best. Alright guys, here is the answer for you. Did you get all your 3 equations correctly done? Balance? If yes, well done. If not, try again. No harm to try. No pain, no gain. Practice make perfect. Alright. Alright, after the peanut type of question of balancing a chemical equation, now go into the real challenge. We have two parts of the question. Part 1 require you to calculate the heat of combustion based on the given information. While part 2, we are going to change the volume of the water and also the mass of the alcohol used for you to calculate the temperature rise. Can you accept the challenge? Let's move on. Well guys, how do you feel now? I believe some of you find out that the question is pretty easy, but I can also predict that some of you scratching your head, hair fall, and you are having headache now. No worry. As I'm your angel teacher, I will guide you throughout your journey. I won't leave you alone. Now let's look at our part 1, baby step, part by part. Step 1. What we are going to do is we are going to find out the molar mass for propan 1-ol, which is 60 gram per mole. For this one, you need to know how to write the chemical formula. If not, God also cannot help you. Step 2, we are going to calculate the number of mole for 2.36 gram of the propan 1-ol used, which we are going to get 0.039 mole. Alright? These two steps are easy and each of them will award you 1 mark each. Okay, after we have done 2 steps previously, now following up will be our step 3 to calculate the heat change. Remember, the formula is always MC theta. The M is coming from the volume of the water that pour into the copper can, which is 400 ml. And the temperature rise. Okay, we are going to heat the water until 60 degrees Celsius. So the data that we need to use here is 60 degrees Celsius. So what we get 100.8 kilojoule. Please always remember that to convert your unit from joule into kilojoule before we proceed on to steps number 4. Steps number 4, we are going to determine now the final heat of combustion. What we are going to do, we take the heat change, which is 100.8 kilojoule, divide by 0.039 mole, and we get negative 2584.62 kilojoule per mole. Why negative, teacher? Why? Because heat is released to the environment. So the symbol negative here represents heat of combustion is definitely an exothermic reaction. Get it right, guys? Well, I hope that you guys are slowly follow the track. Now we are moving on into part 2, which is more challenging question. We give you a more volume of water and also the same alcohol, higher volume, higher mass of the alcohol used, but now we don't want you to calculate the heat of combustion. Instead, I would wish to know what is the temperature rise. For your information, if you are using the same type of alcohol in the experiment, the delta H for the alcohol should be the same. Here is the hint. So now, teacher is waiting for your answer. Oh dear, don't cry. It is not the end of the world. As you see, your angel teacher is here again to guide you step by step for your part 2. Okay? Well, step 1. Always calculate the number of moles. Since we know that we are using 3.54 gram of propan 1-ol, okay, after we do the conversion, we will get 0.059 mole. Okay? Then after that, step 2 will be a little bit tricky. We use the formula delta H equals to Q divided by N. But now, we already know the delta H from the previous question, and we are calculating the number of mole from step 1. So we need to find out the heat change. So actually what we need to do is your delta H multiplied by 1000 so that it will convert back into joule, and then you multiply with the number of mole that you obtained from your step 1 just now, and therefore you can get your heat change without any problem. And lastly, once we have obtained the heat change, we just need to modify a bit our Q equals to mc theta, because now our last step here is to calculate the temperature rise, which is a theta. So based on the calculation, what we can obtain here is 48.4 degrees Celsius. Remember, final answer must always have a unit. If not, you will lose your mark. Okay. Okay, now it's time for teacher to test your power. Okay, let's spend some time to do these 3 questions. The answer will follow up later on. All the best. Well, as I promised, here is the solution for the questions that I challenged you just now. Okay, follow the steps to check whether you miss any parts of it or do you do any careless mistake. Always remember, practice make perfect. If you do mistake, please don't feel shy to redo it again. Alright guys? Well guys, here's the end of the class and also the end of the sharing from me, Teacher Susan. I hope you enjoyed the lesson. Okay, please don't forget, like my video, share it out and subscribe. As you can see, my YouTube channel, the link is provided for you. See you guys again. Bye!